in order to attain optimum efficiency. One such method of combining data is data blending in Tableau. Hi all, this is Upasana from Edureka, and in this module we're going to talk all about data blending. But before we begin, let's discuss our agenda for today. So first of all, we're going to talk a little bit about the objective of data blending. Then we're going to talk about what data blending essentially is and how it works in Tableau. Then we're going to discuss a concept called joining and see how is it different from data blending. Then we're going to see how can you do this. It's going to be a very short demo, a few simple steps. And finally, we're going to discuss a few limitations in this process. So without much ado, let's get straight to the module. So what is the objective of data blending in Tableau? Why do we need data blending? Now let's suppose you have transactional data stored in Salesforce and quota data stored in an Excel workbook. The data you want to combine is stored in different databases and the granularity of the data captured in each table is different. So in such a case, you use data blending. Now data blending could be very useful under a few conditions. Like you want to combine data from different databases that are not supported by cross-database joins. Now cross-database joins do not support connections to cubes. Take Oracle Essbase for instance, or some extract-only connections. Take Google Analytics as your example. In this case, set up individual data sources for the data you want to analyze and then use data blending to combine the data sources on a single sheet. Next is when you have data at different levels of detail. Now sometimes one data set captures data using greater or lesser granularity than the other data set. For example, suppose you are analyzing transactional data and quota data. Now your transactional data might capture all transactions. However, quota data might aggregate transactions at a quarter level. Because the transactional values are captured at a different level of detail, in each data set, you should use data blending to combine data. Now, third case is when you have a lot of data. Typically, joins are recommended for combining data from the same database. So join is basically another method of data merging in Tableau. We shall discuss it in depth in the later parts of this module. Now, joins are handled by the database, which allows joins to leverage some of the database's native capabilities. However, if you're working with large sets, joins can put a strain on the database and significantly affect performance. In such a case, data blending might be of great use to you because Tableau handles combining the data after the data is aggregated. There is less data to combine. When there is less data to combine, generally performance improves. And finally, you can use data blending when your data needs some cleaning. If your tables do not match up with each other correctly after join, set up data sources for each table. Make any necessary customizations, which basically will include renaming columns, changing column data types, creating groups, and so on and so forth. Then you can use data blending to combine the data. Now that we know when to use data blending, let's find out what data blending actually means. So data blending is a method to combine data that supplements a table of data from one data source to another data source. For people who use SQL, it is basically an advanced version of your left join. Now, what is a join and how is it different from blending data in Tableau? Now, data blending simulates a traditional left join, which I had mentioned a few seconds ago. The main difference between the two is when the join is performed with respect to aggregation. Now, when you use a left join to combine data, a query is sent to the database where the join is performed. Using a left join returns all rows from the left table and any rows from the right table that has a corresponding row match in the left table. The results are then sent to Tableau to be aggregated. For example, suppose you have the following tables. If the common columns are user ID, a left join takes all the data from the left table as well as all the data from the right table because each row now has a corresponding row to match. Now, how is it different from data blending? Now, when you use data blending to combine data, a query is sent to the database for each data source that you're using. The results of these queries, including the aggregated data, are sent back to and combined by Tableau. Now, take for instance, you have the following tables. Again, the same tables. If the linking fields again are user ID on each table, blending your data takes all the data from the left table and supplements the left table with the data from the right table. The view uses all the rows from the primary data source, the left table, and the aggregated rows from the secondary data source, which is the right table, and it is done based on the dimension of the linking fields. If there are multiple values for rows, an asterisk is shown. Measure values are aggregated based on how the field is aggregated in the view. In this case, not all values can be a part of the resulting table because of two reasons. First, a row in the left table does not have a corresponding row match in the right table as indicated by the null value. And second, there are multiple corresponding values in the rows in the right table as indicated by the asterisk or the star sign. Now, suppose you have the same tables as before, but the secondary data source contains a new field called finds. Again, if the linking fields are user ID, blending your data takes all the data from the left table and supplements it with the data from the right table. In this case, you see the same null value and asterisks in the previous example in addition to two things. Now, because the finds field is a measure, you see the row values for the finds field aggregated before the data in the right table is combined. As for the previous example, a row in the left table does not have a corresponding row for the finds, and that is why it is indicated by the second null value. Now, how can you blend your data? Now, you can use data blending when you have data in separate data sources that you want to analyze together on a single sheet. Example I'm going to show you now demonstrates how to blend your data from two different sources. Now, for this, I'll be moving on to my Tableau desktop. And here I'm going to be using two data sources named the Sample-superstore, which is already included in the sample datasets of Tableau, and the sample coffee chain, which is another very easily available dataset for Tableau online. So first, I have already loaded the sample coffee chain to Tableau, and now here is its metadata. We see profit, margin, sales, COGS, total expenses, marketing, inventory, budget profit, margin, budget sales, etc., etc. And this is all in an MS Access database file. Here you can see all the various tables and joins that are there in this query right here. Next step is adding a secondary data source. So what we're going to do is we're going to add a secondary data source named Sample-superstore by again following the steps. It's pretty simple actually. All you have to do is click on this add button and you will find the data set right there. You can search for the data set here and that's it. Here we have both of our data sets. Now blending your data. These are both our metadatas. We're going to go to our sheet. Now what we can do is we can integrate the data from both of the sources based on a common dimension. So when I select this, go to state. So what I'm going to do, I'm going to select the Sample-superstore, go to the profit ratio, put it in my columns. Then I'm going to rows. I'm going to be selecting state, putting it in the rows shelf. Then I'm going to select this chart. Let's try the Gantt bar. Nope, automatic it is. Now, if I go to my coffee chain query and if I look at my state dimension, what do I see here? This is a small chain-like image that is appearing near the state dimension. This basically indicates that the common dimension between the two data sources is something called the state. If I open my other data source as well, which is the Sample-superstore, this is my common dimension. And the chart here basically shows how the profit ratio varies from each state in both the superstore and the coffee chain shops. And that was it for our Tableau desktop. Let me go back to my presentation where we can go ahead. Now, limitations of data blending. Now, what are the constraints that apply to this method? First of all, blending with non-additive aggregates. Now, there are some blending limitations around the non-additive aggregates, such as your count_d, median, and raw SQL aggregate. When you blend on a field with a high level of granularity, suppose date instead of year, let's say, queries can be slowed down. So basically, the speed of the query gets compromised. Null values appear after blending the data sources. Now, null values can sometimes appear in place of the data you want in the view when you're using data blending. And this happens because of a few reasons. It can be so that the second data source does not contain values corresponding to the primary data source, or the data types of the fields you are blending are on different levels of detail, or the value in the primary and secondary data sources use different casing. It can be anything. But the null values sometimes after data blending appear in place of the data you want to view. And finally, sorting by fields is unavailable for data blended measures. But despite that, data blending is a whole new approach to merging of your data. It saves you a lot more time, makes your system way more efficient, and optimizes the data cycle as a whole. With that, I would like to take your leave. Thank you and have a great day.